There's some very important characteristics that help us decide whether a function is linear or whether it's nonlinear. So when we're looking at a table, what we want to look at is the rate of change for the x and y values. First, we want to make sure that our x's are counting up by the same. If we look at our x's, I'm going up by 5, up by 5, up by 5, and up by 5. So I know that I'm going up at the same amount every time. So that's what we're looking for. Once we know that we have that, then we want to check the y values. To get from 9 to 7, I subtract 2. From 7 to 5, I subtract 2. From 5 to 3, I subtract 2. And from 3 to 1, I subtract 2. So this one is linear. Well, we want this in a complete sentence. So we should say, this is linear because there is a constant rate of change. Be careful, folks, when you're supposed to be writing in complete sentences. A lot of you are writing things like linear because there is a constant rate of change. That's not a complete sentence. You haven't started with an explanation. So you need to make sure you say this is linear, or the function is linear, or I choose linear because you've got to have it set up to be a sentence. Looking at a graph, we can see that this is sort of a wavy curve. The only time that something would be linear is if it makes a straight line like this. So the answer would be this is nonlinear because it is not a straight line. Those ones are easy. Ordered pairs, the best way to look at this is to put them into a table because we want to be able to see rate of change like we did before. So we have -3, +2, -2, +4, -1, 8, and 0, 16. So we want to look at the rate of change here. The x's are going up by 1 every time. So here I do +2, and then +4, and then +8. So you can tell this is nonlinear. This is nonlinear because the rate of change is not constant. There you go. Just switch it to a table, and then it looks like the first example. When we're looking for equations to decide whether or not they are linear, we want to make sure that it can be written in the form y equals mx plus b. Now, you might have to do some rearranging to that equation to get it to look like y equals mx plus b, but if you can write it that way, then that's great. This equation is not in y equals mx plus b form because in y equals mx plus b, there's an exponent here that is to the first power. We don't have to write that because anything to the first power is just itself. But so because this equation has a power bigger than 1, it is not linear. So the equation is nonlinear because you could just say the x is squared. That would be a good enough explanation to say why. Or you could say because there's an exponent greater than 1 on the x, you could explain it in any way as long as you explain the fact that it has an exponent bigger than 1. Now, what you want to be careful with is it would not be good enough to just say it can't be written as y equals mx plus b. Because while that is part of the definition, you've not referenced this specific problem. So if you're going to say something like that, you can say it cannot be written as y equals mx plus b because the x is squared. You need to make sure you reference the problem that you were given, because your job when you're explaining something is to tell me why this specific example doesn't work, not just how you know if an equation is a function.